Hello everyone and welcome back to the channel. Today we are diving into the world of Autodesk Revit with a tutorial on creating a custom pipe shoe. Pipe shoe are a crucial support element in piping systems, helping to stabilize and protect pipes. For this tutorial we'll be following the Dutra Max catalog specifications, which I have already prepared to streamline our process. Our goal is to create a versatile pipe shoe family that includes two distinct types, one with a simple T-post for pipe diameters up to 150 and a second using two L-shaped profiles for diameters DN 200 and above. By combining these two into a single adaptive family, we can ensure efficiency and flexibility in future projects. So let's jump right in. In the end of the video you will find a quite interesting section with the bug that I discovered over developing of this family. It might save you some nerves in future, so do not hesitate to watch video until the end. To build our adaptable pipe shoe family, we will start by creating two separate subfamilies for the structural elements, one for the T-post and another for L-profile. This will form the foundation of our main family, allowing us to switch seamlessly between designs based on pipe size. We will begin with the T-post, setting it up in its own family file, and then move on to the L profile. Once we have both ready, we'll combine them along with a clamp family into a single unified structure. For the T-post, open a new family using the metric geometric model template. The first step is to create reference planes that define our geometry. Reference planes act as a guide for dimensions, so we will set up 3 planes for thickness, 2 for width, and 1 for the length. These reference planes will ensure our T-post maintains consistent proportions, even if we adjust the dimensions later. Once the planes are in place, we will add dimensions and equalize them to establish symmetry. Let's label these dimensions for clarity: W for width, T for thickness, and L for length. Link each of these parameters so we can easily modify them as needed. This setup gives us a flexible framework for our T-post. With the reference planes and parameters defined, we are ready to build the geometry. We will use the extrusion tool and create our T-post. After creating the shape, link it to the planes to ensure everything stays aligned and connected. This linkage is important because any changes we make to parameters will now automatically adjust the T-post geometry, keeping it proportional. Finally, link the extrusion to the length property, so the overall shape is responsive to adjustments. Adjust it to match our reference dimensions with a height around 100 mm to align with standard pipe shoe requirements. Now our T-post family is complete. Next we will create the L-profile family, which we will use for large pipe diameters of 200 and above. Start by opening another new family with the metric generic model template. Switch to the front view and begin by adding reference planes to define the key measurements of the profile. We will need planes to represent the inner and outer distances, the width, which we'll label A, and the thickness of the profile itself. We will also set up planes for the profile's main height and the secondary height for the additional reinforcement. These reference planes form a precise and adaptable framework for our profile. With the planes in place, we will now add dimensions for thicknesses, width, and both heights, labeling them as A for width, L1 for the width of two profiles, and height for the main height and H1 for the secondary height. Using the extrusion tool, we will create two L-shaped profiles and link them to the reference planes. This way they stay proportional and align with any adjustments we make to the parameters. Switch to the reference level view and add 2 more planes to indicate the profile length, labeled L. Link the geometry to the length dimensions to finalize our L profile structure. Ensure it's ready to integrate with other parts. And the final step will be to add a few additional reference planes to indicate the reinforcement plate. Now that we have created the T-post and L-profile subfamilies, it's time to bring them together in one main family. Open a new metric generic model family and load the T-post, L-profile and the clamp family we created earlier into it. To ensure each component is correctly positioned, add a few reference planes. Start by positioning the clamps, centering them in the view. Avoid locking them in place to allow for easy repositioning when needed. Once the clamps are centered, link them to the reference planes to maintain alignment. This setup provides flexibility and adaptability, allowing the pipe shoe to work across various sizes and configurations. Now let's switch to the front view to adjust the clamps. We will rotate them by 45 degrees, which aligns with our setup, and add the property to adjustable angles. This is important because for larger diameters, the angle needs to change to 30 degrees. Here we can see that the center line of the clamp with a small offset. That means that we forgot to enable one of the reference planes. For that, let's open the clamp family and adjust it a bit. Make sure everything aligns well. Take your time here, as accurate placement will prevent issue in real-world application and ensure the shoe maintains stability. With the structural elements set, we will add some properties that will make sure this pipe shoe responsive to different sizes. Shared properties like nominal diameter, description, and other properties like A for the width, L for the length, and H for height, and all remaining properties. Before we can continue, we need to add one additional property to define the offset of the T-post and L profile. That will be equal to H1 multiplied by -1. To link these properties to the varying sizes, we will use a lookup table saved as CSV file. File will map out each size, allowing us to adapt dimensions automatically. Load the CSV file into Revit, making sure it's correctly linked to our family properties. This approach will give us a versatile family that scales based on size requirements. Now we need to connect the lookup properties with the loaded profiles. Now we will add the condition that reflects the requirements of the rotation of the clamp. When it's below DN 200, that it should be 45, and when it's above, then it should be 30. Next step will be to add additional property to operate with the object appearance. So in case when the diameter is below DN 200, then T profile will appear, and when it's above DN 200, then L profile will appear. Don't forget to add the brackets, so it will ignore the case. As we are ready with the main geometry, let's fine-tune some places. As we are missing a few dimensions from the vendor catalog, we will measure it from the model and add to our lookup table by adding 2 additional columns. We need to do it only for the N200 and above. as we are facing this issue only with the L profile. Before we start, let's update the condition. Let's open L profile and add one additional reference plane and label. Adjusting geometry accordingly. We need to measure it size by size and check it accordingly. Updated table is ready, so let's load it back to our family and add missing properties. If you remember, we created the clamp family only up to DN500. And now, to make sure that we can create pipe shoe up to DN700, we need to update our clamp family accordingly. When you're dealing with properties of category family type, you need to make sure that all the family linked to each other contains the same properties with the same names. And now we need to adjust it. Finally, we'll add connectors to the pipe shoe family, classifying it global. These connectors will allow the pipe shoe to interface correctly with other elements in the Revit project. To complete the setup, make sure each connector is aligned and linked to the normal diameter properly. Once this is done, set the family category and let's load into a project to test its functionality. Currently we ran into an issue due to the category of family was selected incorrectly. So now we need to change the category of family to pipe accessories and adjust for a bit the connectors to ensure that our family will not be rotated after insertion. Adjusting the properties will confirm that the geometry adapts dynamically as we switch sizes. And that's it, a versatile pipe shoe family that can handle different pipe sizes and configurations, all within one family file. We've effectively combined two pipe shoe designs, ensuring a flexible, efficient setup that you can reuse across various projects. Thank you for watching. I hope this tutorial has been helpful. If you enjoyed it, please like, comment and subscribe for more Revit content. And as I promised, here is a bug that I encountered over development of this family. You might run into the same issue as I just. When you're dealing with the properties like family type, you need to make sure that both of the families have same property names and also try to avoid using the property with the names considering different cases. So for example, if you have a property as a h small 1 and in another one you have property h capital 1, it might overtake this value even if you don't want it. So in this case, use different names just to make sure that you are safe. Thank you for watching and see you next time.